Hello learners, I am Dr. Munish Bhardwaj from School of Engineering and Technology of IGNOU. As you know, we were discussing about repairing materials for defects in steel. So today we will discuss about the part 3 of this topic. As you know, till now we have discussed coatings and protective layers, in which I discussed with you various type of platings. Then I discussed with you design and construction practices. Then we discussed about methods of excluding external source of chloride ion from concrete. Then we discussed about methods of protecting reinforcing steel from chloride ion. Then we moved to corrosion control methods, and also we discussed about remedial measures to rehabilitate affected structures. Now, in this lecture, I'll discuss with you case studies on protection of reinforcement from corrosion. And in this two case studies, or rather two type of case studies we will cover. First is corrosion of steel reinforcement due to aggressive marine environment, and second one is corrosion of steel reinforcement due to aggressive chemical environment. Let us begin with corrosion of steel reinforcement due to aggressive marine environment. One of the projects constructed at Port Blair, which is a highly corrosive zone, demanded special treatment to the steel reinforcing bars against corrosion. For the construction, no pit sand or river sand is available there, hence only sea sand from sea coast can be used for construction. As you know, the chloride content in the sea sand is about 4000 ppm, very high, whereas IS code 456 imposes a restriction on chlorides at 2000 ppm for plain concrete and 1000 ppm for reinforced concrete and 500 ppm of sulfate in the mixing water. The sea sand is collected and thoroughly washed with potable water in a specially constructed tank, and the washed sand is used for the construction work. As a measure of abundant precaution against corrosive atmosphere prevailing there from causing corrosion of reinforcement, and also to prevent corrosion of reinforcement by the chlorides in sand, the method developed by Central Electrochemical Research Institute was deployed. This method basically involved acid pickling on reinforcement rods for removing rust, rinsing with good copious water, applying phosphate jelly immediately, and applying the sealing compound as a corrosion inhibitor. So this was used for making the steel corrosion resistant. The various processes involved are indicated. Different tanks necessary for carrying out all the above three treatments have been constructed, and the treatment of rods done and used in the work. The precautions to be taken are all the rods before treatment shall be cut and bent to the required shape, treated and used in work without damaging the treatment done at the earliest. Because if you are cutting or bending the reinforcing bars after treatment, then it will be destroying the protecting layer. While handling, fixing, tying and other operations, if anywhere the treatment gets affected, the inhibitor is applied with brushes and then only used. This treatment was followed in constructions like Pamban Road Bridge near Rameshwaram, North Madras Thermal Scheme and other such important works. Now let's move to corrosion of steel reinforcement due to aggressive chemical environment. In one of the chemical plants constructed near Alvai in Kerala, severe corrosion problems were facing in the structural members of the process house. Due to the aggressive chemical vapors emanating from the process house, reinforcement in concrete slabs, beams, columns, concrete parapets, RCC jali work of the building and the brick walls of the structure were corroded severely. The structure was constructed in 1978. The process house, where the main chemical activities are taking place for the production of ammonium perchlorate, is a 3-tier building in reinforced cement concrete. The chemical process produces a very aggressive environment due to the spillage of ammonium reacts with the lime content in the cement sand matrix present in the concrete and brickwork, thus rendering them weak and resulting in severe corrosion and deterioration. What distress was noticed there? Due to the aggressive chemical environment inside the process house, some distresses in structural members were noticed during 1982 and 83, and they were in floors. What happened there? The cement sand matrix on the surface of first and second level mezzanine floors was gradually eroded, exposing the stone aggregates. In reinforced concrete beams, what happened there? Formation of longitudinal cracks were observed in beams at first and second level mezzanines, accompanied by spalling of concrete and brownish color formation at the soffit of the beam. Water dripping and oozing out of brownish liquid from the beam around the crystallizer equipment was also observed. Then what was observed in reinforced concrete handrail posts and RC jali works? In the handrail posts and jali, the reinforcement was corroded and spalling of concrete was noticed. These members were not only exposed to chemical vapors, but they also came into direct contact with water and ammonium perchlorate. Then what happened to mild steel members? In mild steel members, corrosion of all exposed mild steel items, including exhaust fans, was observed despite frequent painting. Means painting also could not protect the items from corrosion. This resulted in the splitting of the cover concrete, where the mild steel inserts are embedded in concrete. Now, what were the causes of deterioration? Cement concrete normally provides a highly alkaline environment that protects embedded steel against corrosion. Well compacted concrete with low water content minimizes penetration of corrosion inducing elements like oxygen, chloride ion, carbon dioxide and hydrogen. The high alkalinity of the hard gel in concrete may be lost by bleaching or by carbonation. Oxygen and water are required for corrosion to occur, that you know. Chloride ions in the cement will be responsible to destroy the protective alkaline film formed on the steel. Reinforcement embedded in concrete expands due to corrosion and cracks develop in concrete along the reinforcement. The ammonium perchlorate assisted by moist conditions react with the lime contents in the cement sand matrix present in the concrete, leading to deterioration. In case of reinforced concrete, the ammonium perchlorate reacts with the cement sand matrix and reduces the highly favorable alkaline condition in the concrete around the reinforcement, and this has resulted in severe corrosion of reinforcement. The onset of corrosion of reinforcement and other mild steel embedments in concrete resulted in the splitting of cover concrete, particularly at locations where reinforcement cover was inadequate and porosity of concrete was more. The operation of centrifuge mounted on the mezzanine floors caused considerable vibration of RCC floor, resulting in faster penetration of processed water into the concrete. What remedial measures was taken? The following restoration works were carried out during early 1988, taking into consideration that only a very short duration of slowdown is possible. The floor surfaces were thoroughly cleaned after removing all the loose and weak concrete using wire brush and water gel. The rough concrete surface was then provided with a fresh layer of M15 grade concrete with weld mesh reinforcement. The concreting was done in alternative panels of 10 square meter sizes with thickness varying from 40 mm to 150 mm to ensure adequate slope to drain out the processed water. After proper curing and drying, the top surface was provided with 6 mm thick epoxy overlay with the following specifications. The specifications were: primer coat was applied to the prepared surface using araldite GY250 as binder with hardener XY45 in 1:1 proportion. The mix was applied using nylon brush to the concrete surfaces within 15 minutes from the time of mixing. A mix using 100 grams binder and 100 gram hardener gave a coverage of about 0.2 square meter. The surface was then provided with an overlay of epoxy mortar prepared in the following proportions. What were taken? Binder was taken as araldite GY, amount was 250 to 300 grams. Hardener, 3 different hardeners, HY 100 grams, then hardener HI 840 grams, then hardener HY 850 grams. Then filler, quartz sand was used as filler, number 10, and the amount was 1000 grams, means 1 kg. So this was the proportion to make the overlay. The above mix was spread and finished using trowel within 30 minutes from the time of mixing binder and hardener, and it gave a coverage of 0.2 square meter with an average thickness of 50 mm. The epoxy treatment rendered the floor impervious. So once you make the surface impervious, then you can get rid of the problem of corrosion. For RCC beams and columns, the spalled concrete was removed and the corroded surfaces were thoroughly cleaned. The surface was treated with epoxy primer coat and the sections made good by applying epoxy mortar of same proportion. In case of RCC parapets and jali works, where the damage was extensive, they were removed and they were rebuilt. Then what distress was noticed further? It was observed that the restoration work carried out during 1986 using concrete for regrading and topping the surface with epoxy mortar effectively arrested the ingress of processed water into the treated surface of the floors by forming an impervious surface. However, the patch repairs done to cracks in beams and columns were found to be cracking and debonding, and fresh cracks were observed in some locations, indicating that the residual chemical still had its continuous effect. At locations where the distress was severe, the loose and split concrete was removed, and it was observed that the outer layers of the main reinforcement and stirrups had appreciably reduced in their cross-section due to corrosion. The nature of deterioration noticed demanded immediate rectification. This is due to the fact that reduction of cross-section of reinforcement results in the loss of overall strength of the structure and call for immediate repairs. It was observed by a specialized committee that further development of cracks occurred in many of the structural members even after frequent repairs. In view of the extensive damage that occurred prior to the treatment and also further distress that occurred within a short period of treatment, it was felt that the rate of corrosion that was occurring in the structure appeared to be beyond control. Under such circumstances, it was decided that it was not viable to rectify the building to restore the original safety and serviceability conditions. Then finally it was recommended by the committee to construct a new building for the process house, taking into account the various protective measures to be considered right from planning and design stage itself. Then suggestions or recommendations for design and construction of structures subjected to chemical environment. What are the design aspects? The floors supporting the equipments shall be delinked from the main building, providing independent supports and foundation for the members of such floors. Then structural systems should be simple and slender members should be avoided. Provide crack-free sections with the stress in the steel kept as low as possible. Then design of a suitable concrete mix taking into account low water cement ratio, well graded aggregates and adequate quantity of cement to satisfy durability considerations. However, the design mix should not be less than M20 grade. In order to keep the water cement ratio low, it was recommended to use suitable plasticizer as water reducing agent. A few trial mixes shall be carried out to arrive at the most appropriate concrete mix. The specifications should also include adequate cover thickness, namely minimum 50 mm for columns and 30 mm and 40 mm for slabs and beams respectively. As a matter of corrosion protection, the following measures are recommended. What are these measures? To adopt a good concreting practice to ensure a good quality concrete by proper placing and compacting. Because if you are able to prepare a good quality concrete which is almost impermeable, then we can ensure that corrosion will not be there. Number 2, to provide a corrosion resistant coating for the reinforcement if necessary. If environment is very aggressive, then it is recommended that the corrosion resistant coating should be applied to the reinforcement. The use of non-corrosive metals such as stainless steel wires or appropriately coated wires should be used as binding wire for tying the reinforcement. The flooring should be provided with a protective overlay, preferably of epoxy based material. Now let's see some general precautions. Mild steel inserts for supporting service pipes etc. should be avoided, and RCC supports should be provided at intervals. In lieu of this, PVC inserts may be used. Avoid embedment of electrical conduits and pipelines inside the concrete. Chilling plant and compressors should be delinked from the main process house and provided with vibration isolation. Electrical panel, switchboards should be preferably kept outside the process area. So this way we discuss about the materials or the repairing materials for steel, in which we discussed about various coatings and protective layers, then design and construction practices, then methods of excluding external sources of chloride ion from concrete, then methods of protecting reinforcing steel from chloride ion. Also we discussed corrosion control methods, and then we discuss remedial measures to rehabilitate affected structures, and finally we discuss case studies on corrosion and how to protect the structures from corrosion. So you must have enjoyed this discussion. Thank you.